Hello friends, so far we have dealt with problems involving simple harmonic motion, okay, the free oscillations or natural vibrations, right? Here we are going to talk about uh, something called damped oscillations. We have done theory of that and we'll be doing a numerical problem on that here. The amplitude of damped harmonic oscillator, it reduces to half in 1 minute, and after 3 minutes it reduces to 1 upon x, and we have to find the value of x. Okay, now first of all we need to recollect what is the amplitude of a damped oscillation, right? So amplitude of damped oscillation is equal to AD, I would say, okay, and it is equal to A into e raised to minus bt upon 2m. Okay, now here t is the time period and b is the damping constant, m is the mass, and a is the amplitude of free oscillation, okay, the maximum amplitude or the beginning amplitude. Okay, and now they say that amplitude it reduces to half in 1 minute. Okay, half in 1 minute, and after 3 minutes it reduces to 1 upon x. Now here your time is given in minutes. Do we really need to change it? Okay, or do we really need to convert that those minutes into seconds? For the time being, let us not. Okay, uh, let us substitute the first condition. They say it reduces to half in 1 minute. So my AD is equal to A by 2 in T equal to 1 minute, right? So I would say A by 2 is equal to A into e raised to minus B into 1 minute upon 2m, right? So this A I can cancel. Okay, so I would be able to write here as e raised to power minus b upon 2m is equal to 1 by 2. Now do I know b? Do I know m? No, I don't know. Okay, so let us keep it as it is. Okay, now let us substitute the second condition. After 3 minutes it reduces to 1 by x. So 1 by x times the original amplitude. So AD would be equal to A by x in 3 minutes. So again I will substitute that here. Therefore A upon x is equal to A into e raised to minus b into 3 upon 2m, right? So again we cancel this a here, and I can write here as 1 upon x is equal to e raised to minus 3b upon 2m. Okay, what do we do next? I can write this as e raised to minus b upon 2m raised to power 3. I can do that, isn't it? And this e raised to power minus b upon 2m, how much is that? Is it not half here? So I substitute this as half cube. So 1 upon x is equal to half cube. So that means 1 upon x is equal to 1 upon 8, and that means my x is equal to 8. What does it mean? It means that in 3 minutes, after 3 minutes, the amplitude becomes 1/8 of the original amplitude. Okay, now here you notice that there is nothing much that we did here. Okay, but what we did here, we analyzed the data. Okay, just understand the problem. Okay, we could get stuck over here. Okay, because we don't know b, we don't know m. Okay, we don't know, so we wouldn't be able to figure anything out, because if I knew m, I would have been able to find out b. But then what we did, we just kept it as it is, and over here we modified this expression into this, and then for this value I put half here. Okay, so 1 upon x is half raised to power 3, that gives you x is equal to 8. Okay, so that was all about problems in oscillations. I'll be giving some problems in the description on the blog for your own practice, right? Thank you so much.